X and Y. And how we simply do that, because we now to actually get it set up, we will need two things, our first person character and our game mode. Game mode is this overarching class that will tell our world, this little level we created, which pawn, which character, or whatever you want to play with is it supposed to select when it's starting the game. So let's get to creating it. We can use Ctrl Alt to bring our content drawer. Let's dock it in the layout. And create here a new folder. So we're gonna make it a folder and call it core. Inside it we will need one more folder, and that's gonna be for our systems. And here we can finally right click, get here a blueprint class and select a game mode. Let's call it a main game mode to actually let the level know that it should use systems. And in here we can finally right click, get here a blueprint class and select a game mode. Let's call it a main game mode. To actually let the level know that it should use this game mode, we will need to add here a world setting. We can do it here in the Windows and set up a world setting. Here in the game mode override, let's just select a game main mode. Main game mode. There we go. And for our default pawn class, we of course don't have any pawn or character yet. So we're gonna start by clicking on play and seeing that we have here this template card that just let us fly around. Look at the level, but not much of a first person movement. So that's what we will have to set up. Let's go back in our core folder, create another folder, and this will be for our characters. Inside it, we can finally create a new blueprint class. Just so you a little bit understand the hierarchy, actor is a class that can be put somewhere in the world. Android is a pawn, which is a sort of a class that can exist in the world and be possessed by the player. That means you, if you use your gamepad or mouse or whatnot, you can control it. And with a character, we get a bunch of defaults like character movement, gravity, and all these little things. So let's select exactly that we got here. Character, and let's call it our first person movement. Pay for anything else, make sure to save, so either Ctrl S or select save all. And save selected. With this setup, we can open our first person movement, and what we will see here is some capsule, some arrow, mesh, which we don't need, we don't actually care about any mesh. And the promised character movement. We have here a bunch of settings that you can dive into and tune it. We'll touch on it a little bit later, but mainly you take your time and look at all these settings that you can adjust them to your liking. Thing we'll need to do is to make sure that our character gets spawned when we start the game. We can look right in here on default mode and select it in here. So we want to put here our first person movement. Now if we click on play, we get our character and we cannot move anymore, we can look around, nothing like that because we haven't set it up. So let's close the preview and get into setting it up. The second time you open your blueprint, for whatever reason it shows you just this setting, ignore that, open full blueprint editor. And this is where you want to actually be. So now when we open our blueprint, we have here three somewhat important things. We have here a viewport, construction script, and event graph. Viewport is how your character looks like. Event graph is where most of your logic will happen. So that's where we need to be right now. We will start by giving our character an option to look around. So for that, we of course first need some sort of input, and what better input than our mouse. So let's right click here, and we are We are gonna get here our mouse X and Y. These are our X's. Whenever you move your mouse, you either move it up, down, left, right. Then we have so you can think about it as Y or X. I hope I didn't mix up the X's, but I don't believe I did. So we're gonna switch it to mouse X Y to the X's. I'm gonna clarify here one thing. In Unreal since 5.0, 5.1, it's probably better to use enhanced input. I'm not gonna do it here because it's not particularly important, but when you are thinking about making a long-term project, that's what I would recommend. Looking into. I will leave a link to documentation in the description, and I'm also planning to make a tutorial about it. So we got our mouse X and Y. So I would like to see it doing something while I'm in my editor and playing. So let me drag from here and print here a string. String just means some text on the screen. Let's connect it in here, and we're going to run into one quick thing. If I click on play here, my text is gonna be full of numbers. You can see it's changing. It's kind of difficult to see what the hell is happening if it's filling my screen. So I'm gonna do here one quick thing and enable my key. This tells Unreal that the next debug message that will be printed should replace the previous one and not to add a new one on the screen. So let's call it mouse axis. Now I got just one number, and you can see that if I move my mouse, well, you can see me moving my mouse, but you will have to trust me, but you can see the number here changing. So when I'm moving it, it's adding or either X or Y. Perfect. So these numbers we basically want to add to a rotation of our controller. So let's add here a yaw and add here a pitch. These are functions existing in the pawn class, so you don't have to really worry about it. Just think about them as a function that come by you using pawn or character. Now we of course want to connect our X and Y. And how we simply do that, because we have here just a vector that has some weird two numbers, we'll have to break it down, put here a break vector, and connect our X and Y. Let's here. Alright. Compile it all, we can click on play. And now I can move left and right, up and down, and everything seems pretty cool. Luckily, same as with adding input, we have an option to add a movement input. That's and now I make vector and connect our x and y. Let's keep it in here. Alright. Compile it all, we can click on play. And now I can move left and right, up and down, and everything seems pretty cool. Luckily, same as with adding input, we have an option to add a movement input. That's a function coming from our pawn class and will basically push us in the direction we select. Adding input, we have an option to add a movement input. That's a function coming from our pawn class and will basically push us in the direction we select. Deciding at what point, that means what is the trigger for this, is pretty straightforward. We want probably a key being pressed that's supposed to start us moving, and the direction in that case should be forward. So let's see about that. We can right click here and put here a keyboard, and under keyboard we can find W. What's good to be aware of is that with any actor in the game you get few directions right out of the box. You actually get all 6 of them, but you need to do a bit of a math. So we get our forward, right and up vector. What this basically means is that after you click on any of these actors, it will automatically tell it which is its direction forward, right and up. You can see it with these arrows. So this one is forward, right and up. Before we actually set our direction, let's set up the camera. So we can click here on add and put here a camera. You could see that we had a camera before already. That's because engine automatically added the camera in our case, because it knew that we are controlling that character. But now we can add here our own camera, or it may be bit higher, and you have here again a bunch of settings to change. By default, we can keep our FOV on 90, play our game. We are gonna start moving, but now we have introduced another problem. We realize we can now see that our pitch doesn't work. I can move just left and right and not up and down. So this is great if you're making a Doom, but not quite working for us right now. And the reason for that is that by default, even though we are adding our pitch in here, it's not allowed by a controller. And luckily see it if we click on our first person movement and find here our pitch. Let's find here a pitch input, and we want to know if our controller should use a rotation pitch, and we of course want to select it. And interestingly enough, yaw is by default already enabled. So the only one we need to allow is pitch in case we want to use it. Now if we click on play, we can see that our up and down is still working. In my case, it seems like X and Y is reversed. So in case you want to reverse it, very easily, we can simply grab our pitch and multiply it by -1. So let's take it from Y, multiply -1, and connect it right in here. Here, pile, and by pressing easily, we can simply grab our pitch and multiply it by -1. So let's take it from Y, multiply -1, and connect it. Right in here, pile, and by pressing play, we got up going up, down going down. There we go, way more accurate. I actually just realized I made here one pretty big mistake. This code will not work. We gotta disable our outcome movement input, because movement input has to be added every frame over time, because it's moving just a little bit every time you call it. That means calling it once after pressing W is not quite gonna do our job. So yep, nope. We're gonna have to move it up, and we will find here our event tick. Event tick is basically an event that happens every frame. It means every frame of the game, in normal game about 60 FPS, this event gets executed. So what we are gonna do here is connect it our add movement input and set it up with our world direction. So we will need to know whether we want to be walking forward or backwards, because but the direction is actually the same. Going forward and backwards, funnily enough, is the same direction, except the direction is reversed. Which may not make much sense, but in game development you will get used to a lot of things like that. It's the same direction multiplied by -1. So how we do that is basically grabbing our camera, getting its forward vector, that means forward direction, remember the X red axis forward. You can grab it here and multiply it by a value, and that value should be a float. You can just right click on this lower node and convert it to a float. And that float we can actually turn into a variable. Let's promote this to a variable, and that variable should be, remember, the X red axis forward. You can grab it here and multiply it by a value, and that value should be a float. You can just right click on this lower node and convert it to a float. And that float we can actually turn into a variable. Let's promote this to a variable, and that variable should be our forward axis. This is actually a little bit of a hacky way how to do it. We would have much better way how to do it with enhanced input, much cleaner. But I'm actually doing it consciously this way because I believe it makes it easier to understand how the movement in the 3D space works and how it actually happens when you are moving forward and pressing different buttons. Like I mentioned, I'm gonna make another tutorial how to rework it with enhanced input, and the link will be in the description. Let's connect this in our world direction. So what we do now is move all the way down, and our forward axis, we're gonna set this to 1. And our link will be in the description. Let's connect this in our world direction. So what we do now is move all the way down, and our forward axis, we're gonna set this to 1. And after releasing it, we're gonna set it to 0. So clicking on play. Now if I press W, you can see that I am moving forward. If I let go, it's gonna stop moving. And now I'm gonna do the exact same thing with S. So let me grab my W here and convert it into S. Very easy way how to do it. Click on input, press S. There we have it. We can copy our forward axis. Simply set this to -1. Connect on pressed, connect on released. Play. And now moving forward, moving backwards. Still keeping an eye on our camera vector. Everything seems to be working pretty fine. Alright, we can do the exact same thing with our right vector. Right, we're gonna grab all of this. Well, actually just W and S, put them in here. And we're gonna change it to A and D. And now we can get back up here to our equation. Let's move it up. And what we're gonna do is to actually add it up. We can put here a plus with another equation. Can connect it in here, and that's gonna be almost the same thing, except we are gonna change few variables. So we are not gonna get here a right vector, and we will of course multiply it with a different axis. So let's duplicate this, and this is gonna be our right axis. I suppose the proper term would be right multiply. And forward multiplied, but cut me some slack with this. So move down in here. We are gonna do the exact same thing. On the right axis, set it to 1, not 2, 1 please. Copy again, 0, Ctrl C, Ctrl V, multiply by -1, and release on 0. Let's see if it does what we want from it. Okay, click on play, move forward, move backwards, move right, and move right and left is reversed. Exact opposite. I can just quickly reverse it here. This should be D. And this should be A. I just don't want to change all these variables. Alright, compile it. We can get our movement in all 4, technically 8 directions. So seems like we got it working pretty nicely. It's reacting to our camera. It does not let us walk through the floor. I would consider that a success. I'm gonna put here a few debugs just so we can just so it's a little bit easier to understand. So let's put here a print string, and this is gonna be for our direction. So again, remember our key. We're gonna put here a direction, and we will print this value. And I actually would like to make it a little bit easier to see, so I'm gonna actually append this string and connect this to my B, and not just print a value but print the text explaining it. So let's call it current direction and do something like this. What this does on the screen we can see right in here. So you can see our current direction on X, Y and Z is zeros. Nothing. We are not moving, of course. But that doesn't mean that our event tick isn't running. We can scroll down here, make sure that our first person movement is selected in our preview, and we can actually see that our event is still running. We can also see our print string. That means, of course, our event tick is running. So movement is being added, it just does not have any value. So if I move back here and start pressing W, we can start seeing that some values are being added, and those values are just coming from my forward movement. It may be a little bit confusing because we got our X and Y changing, but that's because telling us forward vector relative to the world space. So where exactly is our camera looking? If I just stay on the same place and press W, it's gonna keep the same values. If I press S, it's gonna give me exactly reversed values. If I press A, it's gonna mostly move to the left and to the right. Let me just quickly go over this equation. In case you feel like you don't need it, just skip it. Don't worry about it, man. So what happens here is that we have our forward axis float and right axis float. I'm gonna just focus on my forward right now. So I'm grabbing the forward direction from my camera. You can see it's right this one. Wherever the camera is aiming at, this is where my forward direction will be. So I take the direction and multiply it by a float, by a value. That means numeric value that can be, in our case, between 1 and -1. And what happens here is that if that value is multiplied by 1, that means the forward vector stays as it is. It just keeps on going forward. If it's multiplied by -1, that means when we press S, it's gonna go exactly backwards, because the value there is reversed. And when we release any of these buttons, it's set to 0. which simply means whatever value is here is nullified. It gets multiplied by 0, and anything multiplied by 0 is a 0. Just to quickly keep it in your head, we get the direction multiplied by either 1, that means stays the same, multiplied by -1, that means it's reversed, or multiplied by 0, that means no direction at all. We do the exact same thing with our right vector. And because we are adding them up together, they can technically exist together. So if you press W and D the right corner, that's why I mentioned before we got about 8 directions. Alright, we got it mostly set up. Let's do here one bonus thing, and that's gonna be jumping. So we can just create it in pretty much the same way as we did here. We're gonna make here some sort of a button, and when that button is pressed, it should jump. Luckily we have a function for it already set up as well, so I can just grab it in here, put here a spacebar, and call a jump. So now simply, if I play my game, press spacebar, guess what, I'm jumping. And it was pretty straightforward, nothing too difficult about that. We can now a little bit maybe look into our parameters and see how to adjust them. So the simplest to think about right now is our jump z velocity. It's gonna be about double from what was the default. Default was 420, so if I do it now, you can see that I'm jumping way more than before. Another thing we can change here is our maximum walk speed. So right now, it should be about 600. We can actually even measure it if we want to. Let's add here another debug. So we can put this after it this time. This one is not direction, but speed. And I'm gonna grab my velocity. So get velocity. And at velocity, I want to convert to a simple number. So that's gonna be a length. Let's get here a vector length, and length is simply gonna tell us how fast are we moving. We can change its color, so we differentiate it somehow, and now if we play, our velocity is 0. And now we are almost on 600, little bit lower when we are changing direction, that makes a bunch of sense. In our maximum walk speed, and set it to about 1200. Let's see about this one. Just a quick note, Dio, you can use this pretty nicely to set up some sort of a sprinting. Just like in case you were wondering, we have here a gravity scale, acceleration, braking factor. I would really encourage you to dive deep into these settings and adjust it and tune them to make your character feel unique to your game, so you don't get these default settings that people sometimes just keep on